Mobile money has totally changed the game for so many people, especially across sub-Saharan Africa. I mean, it's a lifeline, it's super convenient, and it's a huge economic engine. But there's a dark side to all this incredible growth, a huge spike in really sophisticated digital fraud. So let's get into it, because what if the very tools we build to stop the bad guys are just as dangerous as the criminals themselves? And just to give you a sense of the scale we're talking about here, look at this number. 2.1 billion. That's how many registered mobile money accounts there are in sub-Saharan Africa alone. That is a staggering number of people who rely on this tech every single day. So you can imagine protecting it is absolutely critical. All right, so where does all this come from? Well, what we're breaking down today comes from a pretty groundbreaking PhD thesis. It's from Dinesh Azamuke at Makerere University in Uganda. And this research, it just tackles one of the biggest challenges in modern finance head-on. The solution proposed here, it's really, really innovative. And this brings us to the question that's really at the heart of this whole thing. What if, in our big rush to make our financial systems secure, the biggest threat isn't just the hackers and the fraudsters, but the very surveillance tools we're building to stop them? This really gets to the core of a huge, huge dilemma. Yeah, and that dilemma brings us to what the research calls the mobile money paradox. It's this fundamental clash between two things we absolutely need: security and privacy. Okay, so on one hand, mobile money is just so convenient and easy to use, which is great, but that also makes it a prime target for criminals. We're seeing this explosion in really complex fraud, things like identity theft, data breaches, and those really nasty SIM swap attacks, where someone literally steals your phone number to drain your accounts. It's devastating. And this really lays out the paradox perfectly. Check it out. To fight the fraudsters, what do we need? We need access to huge amounts of transaction data to train our powerful machine learning models. But to protect our privacy, something that's required by laws like GDPR, we need to do the exact opposite. We have to restrict access to that very same sensitive data. See the problem? The tool you need for security is a massive privacy risk. It is a classic catch-22. So how do we get out of this mess? Well, the research from Makerere University proposes this really fascinating two-part solution. And part one is pretty bold. Just stop trying to use the real sensitive data. Instead, build a perfect artificial copy, a digital twin of the entire financial world. And this quote from the thesis just lays out the goal perfectly. It says, "A promising remedy is to generate private synthetic datasets whose statistical properties are indistinguishable from the real mobile money transaction data." So, in plain English, let's create a perfect copy we can analyze, but one that has absolutely zero real private customer information in. Okay, so what is synthetic data really? It's super important to get this. We're not talking about just fake randomized numbers. No, this is artificially generated data that's been mathematically built to mirror all the patterns, all the trends, all the relationships of the real-world data. The flight simulator analogy is perfect. It feels completely real when you're using it, but nobody's actually in the air. It's all a simulation. So how did they do it? They built this model called MOM-TS-SIM, which stands for Mobile Money Transaction Simulator. And here's how it works step by step. First, you create your digital actors. Think of them like characters in a video game. You got your clients, your merchants, and yeah, even the fraudsters. Then, you give them rules. You use real-world but totally anonymous data to define how they're all going to behave. Next, you just let them loose. You run the simulation and let them interact, making millions of transactions inside this secure virtual world. And what do you get at the end? A super rich artificial data set that looks and feels exactly like the real deal. But wait, building a realistic simulation is great, but it's not enough. How can you be 100% sure, absolutely certain, that not a single trace of real private info accidentally leaked into the model? Well, that brings us to part two of the solution. And this, you could argue, is the most important part of all: a mathematical privacy shield. So this shield has a name. It's called differential privacy. And the best way to think about it is like this. Imagine you've got a group photo. Differential privacy is like adding just enough fuzziness or noise to that picture. You can still totally see the crowd. You can see what they're doing. You get the big picture. But it's completely impossible to recognize any single person's face. It basically makes individuals mathematically invisible, while all the important group patterns are still there. It's a bulletproof mathematical guarantee of privacy. So you take the powerful simulation, MOM-TSIM, you add that awesome mathematical privacy shield,
differential privacy. And what do? You get the final product, MomTSIM DP. And this is the model that creates a synthetic data set that's not just realistic, but is provably private.
All right, so this all sounds amazing in theory, right? A realistic private data set, the holy grail. But the ultimate test is really simple. Does it actually work? I mean, can you take this artificial data and use it to train a machine learning model that can actually catch real fraudsters out in the wild? Yeah, that is the million-dollar question, isn't it? All this cool tech is pretty much useless if the data it creates can't do the one job it's meant for, building a great fraud detector. So, naturally, the researchers put it to the test. First up, they measured what's called fidelity. Basically, how realistic is this synthetic data? How close is it to the real thing? And just look at the total error rate here. The first simulation, MomTSIM, had a tiny error rate of 2.0010. Then, after they added that privacy shield to create MomTSIM DP, the error only went up to 2.0070. I mean, the difference is practically nothing. This proves the data stayed incredibly realistic, even with that privacy guarantee baked in. Okay, next up was the big one, utility. Can this data actually be used to train a fraud detector? So this chart shows the results. It uses a standard grade called an AUC score. Just think of it like a test score from 0 to 1. A score of 0.5 is just guessing, and a 1 is perfect. And look at this. The models trained on the private synthetic data got a score of 0.79. That is almost just as good as the models trained on the actual sensitive real data. The bottom line, it works. It absolutely works. So the results are crystal clear. It is absolutely possible to create an artificial data set that's both guaranteed to be private and powerful enough to build top-tier security tools. The paradox, it can be solved. And this all leads us to the biggest takeaway, the whole point of this explainer, really. It's this incredible idea that we can actually have security without surveillance. So why does this matter? What's the big deal? Well, it's a total game changer, and here's why. For one, it gives banks, researchers, and regulators a blueprint to work together to fight crime without ever having to share sensitive customer data. It means we can build way smarter security tools without giving up our privacy. It lets companies innovate and stay on the cutting edge while still following the law. And maybe most importantly, it strengthens trust in our digital financial systems. And trust, as we all know, is everything. You know, this research from Makerere University, it doesn't just solve a tricky technical problem. It actually lays out a responsible, ethical path forward. It proves that we don't have to make that impossible choice between keeping our money safe and keeping our data private. We can have both. In fact, we should have both. And that leaves us with one last, pretty powerful thought to chew on. If we can use this method to secure something as complex and sensitive as our money, without watching everyone's every move, what else can we protect? Just think about it. What other areas, healthcare, social media, you name it, could be made safer and more private with this amazing model of security without surveillance?